Top Secret Psi Operative Training Mission Reading Passage Bohr Models Mission Understand how atoms are represented in the Bohr model. Tips Remember to beam as you read through the passage below.
Hey, Nikole. What's that you're drawing?
Hi, Aki. Dr. Joshi taught me how to draw something called the Bohr model. It makes it really easy to see all the parts of the atom. At the center of the atom is the nucleus, which is made up of even smaller particles called protons and neutrons.
The protons and neutrons look very similar. What makes them different from each other?
Nikole's drawing illustration shows an atom labeled with the nucleus, proton, neutron, and electron.
They are both relatively the same size and are small particles inside the nucleus. The difference is that protons have a positive charge and neutrons have no charge. The even smaller particles on the rings around the nucleus are electrons, which have a negative charge.
What's with the rings on the outside, though? It sure looks like you are drawing a solar system. Are you sure you are drawing this right?
I definitely am. Here's Dr. Joshi now. Will you explain to Aki what these rings are on my model?
Nikole, I am happy to see that you are practicing your Bohr models. Aki, I would be happy to show you how to draw them as well if you want to learn. Atoms are somewhat mysterious. You know that electrons move around the nucleus at the center of the atom, but scientists have been unable to predict the exact path of an electron. What scientists do know is that based on the energy of an electron, it will orbit the nucleus in a discrete energy level. Energy levels are fixed distances from the nucleus where electrons will orbit the nucleus. As an electron gains or loses energy, it can move up and down these energy levels. Niels Bohr discovered these energy levels and that each one has a limit to how many electrons it can hold. These energy levels are commonly depicted as 2D rings around the nucleus. Drawing them this way allows for anyone looking at this model to see how many electrons are in each energy level. It does, however, give the false impression that electrons move around the nucleus in these neat circular orbits.
So, if the electrons don't move in a circle, how do the electrons actually move?
After further research, scientists actually found that electrons orbit the nucleus in complex three-dimensional orbitals that are much more detailed than the circles Bohr first envisioned. The energy levels are made up of these orbitals that all have very complicated shapes. All this said, the Bohr model is still very useful when trying to understand the structure of an atom. Look at these rules for placing electrons on the Bohr model. 1. The first energy level closest to the nucleus can have up to 2 electrons. 2. The second energy level can hold up to 8 electrons. 3. The third energy level can hold up to 18 electrons. To find the positions of the electrons for an atom, you have to start by putting electrons on the lowest energy level. This is the first ring closest to the nucleus of the atom. After that energy level is full, then you can move on to the next. Let's practice with oxygen, which has 8 electrons in its neutral form. Place the first 2 in the first energy level as shown here. Next, add in the final 6 electrons in the second energy level.
Why did you place 2 in the first energy level? Why didn't you just put all 8 electrons into the second energy level? It can hold 8 electrons.
Well, there are more rules to learn about why electrons go where they do. For now, however, you just need to know that lower energy levels have to be filled up before you can add any electrons to the next energy level. This means that the first energy level has to have 2 electrons in it before you can add any to the second energy level, and so on. Let's look at another example. Sodium. Sodium has 11 electrons in its neutral form. Place the first 2 in the first energy level as shown here. The next 8 will be placed on the second energy level. The 1 remaining electron will then be added to the third energy level.
Thanks, Nikole and Dr. Joshi, for teaching me about Bohr models. This gave me a great idea for an upgrade to our gear.
Make connections. In each box below, write a connection between the text that you just read and either your prior knowledge or something in your life. Reading comprehension questions. Bohr models. 1. Describe the Bohr model of the atom in 2 sentences. 2. Determine the number of protons, neutrons, and electrons in each atom. Table with column headings. Subatomic particles for atoms 1, 2, and 3. Row headings. Protons, neutrons, electrons, and element. Fill in the blanks for atoms 1, 2, and 3. Three. Fill in the missing information and complete the Bohr model for each of the atoms below. Lithium, atomic number 3, atomic mass number 7. Fill in the number of protons, number of neutrons, number of electrons, and label the nucleus with the number of protons and neutrons as well as place the electrons in the correct orbitals. Neon, atomic number 10, atomic mass number 20. Fill in the number of protons, number of neutrons, number of electrons, and label the nucleus with the number of protons and neutrons as well as place the electrons in the correct orbitals. Magnesium, atomic number 12, atomic mass number 24. Fill in the number of protons, number of neutrons, number of electrons, and label the nucleus with the number of protons and neutrons as well as place the electrons in the correct orbitals. Mission debrief. I need you to get Zia caught up on our conversation about the Bohr model. Can you please write up a PSYOPS debriefing report for her about our conversation? We need her prepared for the next hive attack. Thanks. P.S. Be thorough. We don't want Zia missing out on anything. PSYOPS debriefing report requirements. 4 or more on-topic sentences that summarize the reading. No less than 3 vocabulary words from the reading used in your report. 1 additional sentence about something interesting that you learned during this unit.